We have seen how sound propagates through a medium. When the object vibrates, it creates the disturbance in the surrounding medium, and this disturbance is what we call a sound wave. The wave travels in the medium in the form of compressions and rarefactions. But in which direction do the particles of the medium vibrate? Before we answer that question, we will talk about longitudinal waves. What are longitudinal waves? Let me tell you the fancy definition first. Waves in which the particles of a medium vibrate in a direction parallel or anti-parallel to the direction of energy transport are called longitudinal waves. What does that mean? Before we get to the statement, do you remember what parallel and anti-parallel mean? Parallel would be two vectors like this, and anti-parallel will be two vectors like this. Parallel but in opposite direction. Now coming back to the statement, it means that if the wave travels in this direction, then the particles of the medium also move to and fro along this direction only. So the displacement of particles is parallel or anti-parallel to the direction of the propagation of wave. Is sound wave a longitudinal wave? Take this example and try to find out. Yes, sound waves are indeed longitudinal waves. We see this in this example that the particles of the medium are vibrating in the direction of propagation of wave. Sound waves are also called pressure waves. Can you tell me why? It is because the sound wave consists of the repeating pattern of high pressure regions called compressions and low pressure regions called rarefactions through the medium. But wait, hold on. Are there waves in which the displacement of particles of the medium is not in the direction of propagation of the wave? The answer is yes. Let's see one example in which the propagation of the particles is perpendicular to the direction of propagation of the wave. Take a string with one end fixed to the wall. This end is fixed at the wall here, and this one is in your hand. We see a wave when we give the string an upward jerk from this end. What do you notice here? In what direction are the particles of the string moving? Up and down, right? And what about the direction of the propagation of the wave? It's moving to the right. Let me repeat it once. The particles in the string are moving up and down while the direction of propagation of the wave is towards the right. The particles are vibrating in a direction perpendicular to the direction of the wave. Such waves are called transverse waves. So are sound waves transverse waves? The answer is no, and it's because the particles of the medium are vibrating in the direction of propagation of wave. Here is a quick recap of what we did today. We saw that longitudinal waves are the waves in which particles of the medium vibrate in a direction parallel to the direction of motion. Sound waves are longitudinal waves. Sound propagates through the medium in the form of high pressure and low pressure regions. Hence, sound waves are also called pressure waves. And at the end, we saw what transverse waves mean. They are waves in which particles vibrate at right angles to the direction of its propagation. In the next video, we will understand more about the propagation of sound waves. See you there.